What's up everybody? Welcome to the first of a new series we're calling Tech Talk. This is going to be an in-depth dive onto specific parts or specific systems of parts that we've made for our builds. We don't want to have too much in our build series. We want to keep those a little bit more short and sweet. So these are going to be like really talkative, in-depth dives onto some of the parts. We also want to use this to answer some questions for you guys. If you guys ever have any questions, you want to leave them down below. We'll make sure that we go into those on our Tech Talk videos. And let's get right to it.
When we chose the Kia Stinger engine and the Porsche transmission, the two of them both were chosen because they offered a large amount of positive quantities, price, availability, and reliability being very important factors that we chose them for. However, there was one unique problem. Well, there was a few separate problems, but one of the more involved problems that we encountered is that the Porsche transmission did not have provisions for the starter motor to come from the transmission side. So in the Porsche system, the starter motor is on the engine. Now the Kia, the starter motor is also on the engine, but the problem is because the engine was designed to make a large amount of low-end torque, they had a rather large diameter torque converter for their automatic transmission. So the problem with this is that we needed to be able to use the original starter orientation and the starter position of the Kia, and in this case we just kept their entire starter, which means that we're stuck to the ring gear diameter that the Kia came with. So in an effort to do this in a cost-effective way, instead of modifying the bell housing on the Porsche, which unfortunately the bell housing is one piece with the case, so we're stuck with the bell housing or modifying it. Because we can't modify the bell housing, we decided instead to make an adapter. The adapter had to be rather large because we had to stay with the large diameter ring gear and original flex plate of the Kia design, and then neck down to the Porsche diameter. So the problem with this is the actual flex plate is rather thick. So in our bell housing adapter plate, engine adapter plate, we had to clear this before we could reduce the diameter down to the Porsche size transmission. So then it was decided that because of that, the Porsche also was designed to have the clutch a large amount into the actual bell housing. So the Porsche flywheel is actually really thick, and in the lighter racing versions of this flywheel, they're just offset a long ways and thin. So we were going to be basically faced with a situation where we had to use a rather thick flywheel. So I decided the best thing to do was make the flywheel out of aluminum to try to keep the mass within the target mass of what we wanted, of about a 12 to 14 pound flywheel. I started out by designing this test flywheel, and since there were other Porsche flywheels that were available aftermarket that had a aluminum flywheel, we decided to use this insert here that is made by Fidenza. Now Fidenza makes an entire aluminum flywheel for the Porsche transmission, but the problem is it will not fit our Kia engine and is obviously not thick enough. It doesn't make sense to adapt or make an adapter for a flywheel, because the flywheel has to be rather strong and should be directly bolted to the engine. So, that being said, we worked with the Fidenza insert, which is readily available as a replacement insert for their flywheel. They designed a flywheel about the thickness of their original flywheel, a little bit thinner, to test fit it to the engine, to make sure that I had my bolt patterns for the engine flange correct, clutch bolt patterns correct, and the attachment bolt patterns correct for the Fidenza insert. Then the entire assembly was assembled, put into the engine, the transmission was put on, and the clutch was assembled, and then I took measurements to determine how thick the actual flywheel needed to be, both for the pilot bearing hole and the outer surface. So here you can see our finished flywheel in design only, and it is 2.87 inches tall on the outside, and here to the inside is 118 different, 118 thousandths difference to the outer islands. These will attach to and stabilize the flex plate where the normal torque converter would bolt up to. Okay, so I've explained to you our basic reasoning for why we made the clutch and flywheel assembly the way we did, and I've laid out everything needed over here to assemble it, and if you would like, we'll go assemble it. Alright, so here's our finished flywheel. This is made out of 6061 aluminum. The original billet that it came out of was 53 pounds. As it currently is, it weighs 10.87 pounds and has all of the necessary features that we need. One of the more important things when designing something and making something is to consider servicing it. So these slots that are here, so that the bolt sizes are right, we use a slot size that's specifically measured so that our tools would fit well. Condensing on the aluminum because it's cold. Once the moisture stops condensing, that area of the aluminum is heated up. By heating the aluminum up just a small amount, it will expand, making it so that our bearing literally just drops right in. In a few seconds, the bearing will be virtually impossible to get out without a puller. Okay, these are our 6mm alignment dowels, which are used to align and center the clutch cover. These are a 3/1000 press fit. In other words, what that means is the actual diameter of the hole is 3/1000 of 1 inch smaller than 6mm. 6mm is 236, and these are 233.5. Another interesting thing about using an aluminum flywheel is that our clutch cover would normally be held on by bolts. When you're screwing into a steel or chromoly flywheel, having bolts is perfectly acceptable. However, with an aluminum flywheel, we don't want a large number of torque cycles put on the aluminum. The thread will eventually strip or pull out. So, to not have that problem, what I decided to do was to use basically studs. And since I didn't want to have to deal with stud tools, and because this is a two-part design where we have access to the back, I instead decided to make cavities and to use Allen bolts. The Allen bolts are a 12-9 grade, which is stronger than maintenance grade 8, and will be able to deal with a large number of cycles torquing and untorquing. And when the bolts themselves are worn out, we can use a simple Allen tool to remove them and put new studs. Now we're going to use red Loctite and put our 6 studs to tighten our clutch cover into our flywheel. Step before we go test fit it to the engine is to put our starter ring gear and our crank position sensor wheel onto the back of the flywheel. And to do that, we are going to use a couple of small alignment pins and yeah, it goes this way. Let's see, it's going to go like that. And I'm going to put this alignment pin in here. And we're going to put that alignment pin in there. Okay. To hold our part in alignment.
Thank you guys so much for watching our first Tech Talk video. If you guys have any other questions, please leave them down below, especially if you guys have any like real in-depth questions on parts that we've made or parts that we're going to make. If you guys have any questions like that, please leave them down below and we'll make sure to get to them in the next Tech Talk video. See you guys next time.